Okay, so we're going to finish up week 1 of the respiratory system by talking about minute and alveolar ventilation. So we've got two main outcomes here. Ignore that it says M3 there. All right, so pulmonary ventilation. Okay, the way that airflow works is that the first breath or the first air that enters in your lung is the last air to leave your lung, and vice versa. The last air to enter your lung is the first to leave your lungs. Okay, now it's important to know that not everything that you breathe in actually makes it into the alveoli, and that's important because the alveoli is where gas exchange occurs. And so you've got this air that goes into or stays in what we call anatomical dead space. So these are the big airways. So think like your bronchioles and your trachea. Okay, diffusion can't occur there because the distance that the oxygen has to travel through for diffusion is a very large distance. The walls between the trachea and the blood vessels is really big, and so diffusion just can't occur. And so it's important to understand how much air actually reaches the alveoli. And so in order to determine this, we need to know the size of our tidal volume and then the size of the dead space. And we subtract the two, and then we can say, hey, 350 mils, in this case, of air reached your alveoli. Okay. Now, the nice thing about dead space is it doesn't really change. Okay. The volume of your bronchioles, your trachea, stays relatively constant. Okay. There's no way to calculate it. And we're not going to have you calculate it on exam. If you need that information, I would provide it to you. And it doesn't matter if you're breathing 500 mils or if you're breathing 2,000 mils. So let's just say that you're breathing 2,000 mils per breath, and that's a big breath, but it can happen. Okay, so then dead space would be 150. So then you would say that 1,850 mils of that breath is undergoing gas exchange. Okay, and this will help us calculate what's called alveolar ventilation. Now, to start off, we've got something called minute ventilation. And minute ventilation is the respiratory version of cardiac output. Remember, cardiac output is how much blood leaves your heart every minute. Well, minute ventilation is how much air is getting in and out of your lungs every minute. And just like with cardiac output, the formula is the same. We need to know, in this case, how often are the lungs breathing or being used, okay? So how many respiratory cycles are we going through in a minute? So respiratory rate. And what's the size of each breath? Okay, so that's tidal volume. So respiratory rate is like heart rate. Tidal volume is like stroke volume. So in this case, and based on this figure here, let's say that we take 12 breaths per minute, and they're each 500 milliliters. 12 times 500 equals 6,000 mils. We generally convert that into liters, so that's 6 liters a minute. Now, if we want to know how much is undergoing gas exchange, we have to account for that dead space. And so we take this 12 breaths, that's not going to change, and we go 500 minus the dead space. And so that gives us 350. So 12 times 350 gives us 4,200 mils or 4.2 liters per minute. Okay. Now, with dead space, it's important to know that if our breath, the size of each breath, our tidal volume is less than or equal to the dead space volume, that we're not actually getting any air into our alveoli, therefore no gas exchange. Okay, so if my respiratory rate was 100, which is possible, and but my tidal volume was only 15, I'm not undergoing any gas exchange. And so even though my respiratory rate would be 15 liters a minute, or excuse me, my minute ventilation would be 15 liters a minute, my alveolar ventilation would be 0 because 150 minus 150 equals 0. And we can see that from this chart here. Okay, so in this case, we're saying, notice that we're keeping minute ventilation or pulmonary ventilation constant. We're breathing 6,000 mils or 6 liters per minute. So normal breathing, it's 500 breaths or 500 mils per breath times 10 breaths, that gives us 6,000. When we account for dead space, then we get 4,200 mils per minute that are undergoing gas exchange. Now, if we take big, slow, deep breaths, so we increase our tidal volume to 1,200 mils, we only breathe 5 times a minute, we're still getting 6,000 mils per minute or 6 liters per minute into our lungs. But when we account for dead space, 1,200 minus 150 is 1,050 mils. Multiply that by 5, and our alveolar ventilation becomes 5,250. Now, if we're panting essentially, and we're taking 40 breaths per minute, but each of those breaths only getting in 150 mils, okay, which is about a third of a water bottle, 150, that'll give us our 6,000 mils for pulmonary ventilation, but our alveolar ventilation is just 0 because 150 minus 150 equals 0, and it doesn't matter how many breaths per minute. So if I want to become more efficient at breathing, I need to take bigger breaths. And so that is where we're going to end with pulmonary ventilation and alveolar ventilation and minute ventilation.